of Dr. Carol Stoker from NASA Ames Research Center. She is working on the Icebreaker Life mission, which I am very excited about, and I hope it flies as soon as possible. So she will be giving you the information about that momentarily as soon as we figure out the computer problem.
Okay, I guess you can hear me. All right, I'm going to talk to you about the Icebreaker Life mission to Mars. This would be, if we get selected, the first mission since Viking to search for evidence of modern life on Mars. And it's been proposed to Discovery for a 2020 launch. The PI is Chris McKay. I'm Carol Stoker. I'm the project scientist. Spacecraft comes from Lockheed Martin. There's a 1-meter drill from Honeybee Robotics and 3 instruments and a camera. And I will tell you about all those systems. So the rationale for this mission is that the Phoenix mission, of which I was head of the Biological Potential Science Working Group, found evidence of habitable conditions in the Martian high latitude region where Phoenix landed. The evidence for habitable conditions were that there was evidence of liquid water in the form of segregated ice, which forms normally on Earth by freeze-thaw processes. Ironically, the very first place that we dig, Phoenix had a robotic arm and dug into the ground ice in the circumpolar region, northern hemisphere of Mars. And the very first place we did, we uncovered this white ice. There's a huge controversy about what it was and whether or not it was really white. But now it is the iconic image for Phoenix, ironically enough. Other evidence is that, particularly in that site, there was 3 to 5% calcite in the soil. Calcite requires liquid water to be produced. There was also magnesium perchlorate discovered by Phoenix. It actually could be calcium or magnesium perchlorate, I'm not sure, but perchlorate anyway. And its concentration is apparently variable, patchy around the surface. It's a soluble salt, so liquid water appears to be moving it around, or maybe the is moving it around. Another evidence of habitability is that you need energy. You need either sunlight or you need some kind of chemical energy. Well, there are transparent, looking through the Phoenix microscopic imager, there are transparent particles in the Mars soil that would allow you, if you were a microorganism, to hide under them and screen you from ultraviolet radiation, which would kill you, but allow photosynthetically active radiation to allow you to photosynthesize. There is also now recognized a suite of things that you could potentially metabolize if you were a chemoautotropic microorganism. Perchlorate is actually metabolized by a number of microorganisms on Earth. This shows the oxidizers and reducers. Basically, these are called electron acceptors in biological terms. And perchlorate can complex with any of these things. We've now seen methane on Mars, probably not at concentrations where biology would be happy with it. Reduced iron is potentially something you could complex with. And now, Phoenix did not discover this, but now we have seen nitrate on Mars. Nitrate is another another compound which can complex with electron donors and provide an energy source for microbiology. The environmental conditions are fairly benign in terms of pH is 7.8. It's about what it is in the soil in my backyard. But right now, it's way too cold for growth. But climate conditions are often much warmer than they are now. This slide shows why we think that the northern plains can be habitable in modern times. First of all, the elevation is low, so that the atmospheric pressure, at least seasonally, is above the triple point, so liquid water is at least possible, if not stable. So the ice-rich soils in the near subsurface are a potential abode for life if it were warmer. Well, Mars obliquity varies over time, and right now